And welcome back to Mr. Gregoris Math. Today we're taking a look at direct variation and partial variation. So in a previous note, we'd examined how you can tell whether something is a direct variation or partial variation based off of either the graph or a table of values or the equation. And so here we see two graphs. We've got a graph of Julia's earnings, which is her pay over time, and we've got a graph of guppies born in 5 weeks, and it's time and number of babies is our axes. So one of these is a direct variation and the other is a partial variation. It's actually quite easy to see. So this point here, 0, 0, that is the important point that tells you whether or not you're dealing with a direct variation or partial variation. If the graph would extend through 0, 0, then that makes it a direct variation. So clearly, guppies born in 5 weeks is not a direct variation, but Julia's earnings is. And that makes sense because for often many wage-based jobs, if you don't work, you don't get paid. So this would be an example of a direct variation question. Now, we also have to ensure that they're linear, and we can see that these are linear because they have a constant slope. Remember, the slope is the rise, how far it takes to go up from one point to the next, over the run, how far it takes to go from one point to the next horizontally. And so we can draw a triangle and actually count our units. So from here to here, horizontally, we've got a run of 1 week. And from here to here, vertically, we've got a run of, it looks like this would have been 5. So 5 to 10 is 5 guppies. And so we can actually determine the slope of this equation. So remember, our slope is rise over run. So in this case, it's 5 over 1, or just 5. Now the other part that we had to determine was the equation. So the equation required us to have the slope and also the initial value. Now remember, the equation for any line is y equals mx plus b. And we're going to replace the m with our slope that we had just found. We also have to replace the b. Now y and x actually represent our variables. So our x variable in this case is our time, and our y variable in this case is our number of guppies. So b is our initial value. That's where the line intersects the y-axis. So the distance from 0 to 5 here is 5. And so that's the initial value of the amount of guppies that are born in 5 weeks. So plus 5 is our value of b. Let's take a look at doing that for Julia's earnings. So Julia's earnings has 2 nice points indicated here, and it's actually a pretty simple triangle to draw. I'm going to draw the second triangle so that you can see the horizontal and the vertical though. And remember, vertical is our rise, and our rise in this case goes from, it looks like halfway between 25 and 50, so that's 37.5 to 75. So 75 minus 37.5 is going to be equal to a total rise of 37.5. And our run goes from 10 to 5, so that's 10 minus 5, or run of 5. You can see I'm just taking the differences from the farthest out point to the nearest point. So my slope for this particular one, I'll always write rise over run, so that way I can remember that formula. Now my rise is 37.5, and my run is 5. Now I can go ahead and do the division, or I can simplify. I don't like having decimals and fractions all together, so I think I would write this as a decimal. So 37.5 divided by 5 is 7.5. And now I can write my equation. Remember, my equation is always y equals mx plus b. But the nice part about a direct variation is this b part is always 0 in a direct variation. So my y-axis is my pay, my x-axis is my time worked, and I have y equals 7.5x. So it turns out Julia is getting paid a wage of 7.5 or $7.50 an hour. I think Julia should probably contact the Ministry of Labor. Well, join us next time on Mr. Gregoris Math when we take a look at how to use tables of values to determine whether something's a direct variation or partial variation.